My second one is that we estimate testing very wrongly in our organizations. That's a big assumption I'm making. Because when it comes to testing, testing is not just effort and resource, but there's another dimension that is often missing when it comes to estimating testing. You see, we have problems with test estimation, and it's one of my pet topics. But the fact is, any estimation is based upon two elements: effort, 500 man days. I don't know what the difference is between a man day and a woman day. I think women say it's half as much or something. But effort is man days, and people, how many people? So we have 500 man days and 5 people, and it works out our schedule. Okay? Now, it's a myth when it comes to testing. Because any testing we do, whether it's exploratory, whether it's in agile, whether it's in traditional, we need effort and people and quality. Has to. There is a direct correlation between how many days we expect, how many people, and how many bugs we're likely to find. There's a direct correlation. And the thing here is not only a correlation, but we need to then monitor that quality level. So if we're expecting no more than 50 bugs in a 3-week period, and in the first week we hit 100 bugs, we're in trouble, guys. So we must, the challenge for you, we must estimate quality, and we must monitor that quality. Frederick Brooke wrote a book. It's a thin book. He wrote a book called The Mythical Man Month. In that book, he says, it's Brooke's law, 9 women cannot have a baby in 1 month. That is fact. So there are some activities on our projects that cannot be accelerated by putting more people on them. Managers hear that. First thing when things start to go wrong is that we put more and more bodies onto that project, and then we wonder why things go out of control. So once we've estimated quality, we must monitor. We must monitor that quality and report that quality as well. Now, this is a little spreadsheet that we've got within Grove. And I'm not going to show you this one, but I'm going to show you another one. One thing I like about giving away things in Grove, like little utilities, is when people from organizations come back and say, Lloyd, that is really simple. We've actually enhanced it. And I enjoy that. And this guy from Norway actually went away and enhanced our simple version and produced a little bit more complex version, which I'm going to demonstrate to you. But the idea being is we estimate the quality, and then we look at something called the fix rate. So at every iteration, how many defects are going to be fixed by developers? That can be quite easy to do. This is very controversial. Because for every defect that is fixed, how many are they going to put in? This is called an insert rate. Now, we know that this is not 0. It's got to be higher than 0. Marnie Hutchinson says that one of the measures she uses is 20% on average. So for every 5 defects they fix, they're going to put a new one in for you. Use that as a milestone. And the nesting rate, we say, or it's a masking rate, is that, as we start testing, do we ever get to a defect or a series of defects that prevent us going further? Yes? Now, there are defects behind that, and that's what's called masked or nesting rate. And we have to take that into account as well. So let me just show you a quick demonstration of this. Because it's very important. This has come from a guy in Norway. It's taken our model and enhanced it slightly. The one thing I like about this, and I'll demonstrate this in a moment, it's got the number of cycles, the number of iterations, the number of days in that cycle. This is the actual bugs, 125. Out of those 125, 20% are masked. So you can only see 100 of them in the first iteration. Now that's quite a low masked rate, I have to say, to start with. Fix rate is 80%, so the bug's fixed, and the insert rate they've said is 20%. So these are the new bugs that are going to be inserted with those iterations. This is now estimating quality. But what I like about this guy is that he said, well, the elapsed days per test cycle is 3, the maximum number of developers for bug fixing is 8, and the number of maximum defects they can fix per developer is 4. So the maximum per cycle is 3 times 8 times 4 is 96. Now watch what happens. 8 developers that are supporting testing. Never. So when we come up here and we say we haven't got 8 developers, we have 2. Iterations goes up. The maximum number of defects they can fix in an iteration is less. So this is something we can display to managers when we estimate quality and we start to monitor. Now, another thing we want to do is to say, okay, we're expecting this number of defects, but now we want to monitor. This is one I've prepared earlier. We use something called S-curves. So we say over a 10-day or a 10-week period, we're actually going to find 30 defects. And in our bug chart down here, this is what the planned. So if I add what's called a trend line, a polynomial, third order, if I add that, then that's what we expect. This is what's happening. Add a trend line, polynomial, order 3. That's impossible. That's saying on day 7 or week 7, if it's weekly, we're going to go up to about 45 defects and actually then come back down. This is cumulative. So on day 3, we can say to managers, actually, we're not going to find 30. We underestimated the number of bugs. And there's a straight line. If we put in 89, that gives us an S-curve. So we expect on day 3, this is a prediction element, we expect not to find 30, but 90. Now, why is this important? Because 90 defects, 3 times the number of defects, we need bug fixes. We need regression testing. And I put it to you, if we don't estimate the quality, we're doing ourselves a grave disservice. So my challenge to you is when you go back and do any level of estimation for testing, do not forget quality. Put quality back into it. So, challenge number 2.